The concept of renewable energy. Renewable energy refers to the energy derived from natural sources and are continuously replenished in a human timescale. And unlike non-renewable resources or energy resources such as fossil fuels, which are finite and produce severe environmental impacts, renewable sources are sustainable and produces cleaner energy, which aligns to our SDG or Sustainable Development Goal number 7 for affordable and clean energy. The first example of a renewable energy source is our solar energy. Solar energy is derived from the sun's radiation and is captured through photovoltaic panel systems. These technologies convert sunlight into usable energy or electricity. Solar energy is considered renewable because the sun provides an abundant and continuous energy source. It is also a renewable resource, producing no greenhouse gases emissions in the conversion of energy or to electricity. But with its pros, it also has its cons. First, it is weather dependent. Solar energy production decreases on cloudy areas or cloudy days or in nighttime. Second is it has a high upfront cost. Solar panels and installation can be expensive initially. Third is it requires a large space. Solar farms or rooftop systems need sufficient area for panels. And the second example of renewable energy source or system is geothermal energy. Geothermal energy originates from the source of the Earth's surface. Natural heat found beneath the earth. This heat is accessed through wells and drilling and is converted into energy in geothermal power plants. It is a highly reliable renewable source because Earth continuously generates internal heat. Geothermal systems are known for their stability, low emissions, and ability to operate consistently regardless of weather conditions. But again, with its pros, it also has its cons. First is it is location specific. Second, high drilling and construction costs. Third, risk for underground stability or instability rather. And lastly, is complex maintenance.
Next, I will be talking about the two other important renewable energy sources, and that is wind energy, also known as wind power, and hydropower, also called hydroelectric energy. These energy sources come from a natural movements in our environment, the movement of air and the flow of water. They are clean, sustainable, and play a major role in reducing our dependence on fossil fuels. As our world faces climate change, rising fuel prices, and increasing energy demands, understanding how these renewable sources work is essential. So today, let's explore what wind and water energy are, how they work and their advantage and their limitation, and why they are vital for our future. Let's start about wind energy. What is wind energy? Wind energy is also known as wind power. It's the electricity generated from a natural movement of air. Wind is formed by an even heating of the Earth's surface, which causes air to rise, fall, and move. This movement contains kinetic energy that we can capture. How wind energy works. To turn wind into electricity, we use wind turbines. These turbines have large blades that rotate when the wind blows. Here's how the process to turn wind into electricity. The wind hits the blades of the turbines and make them spin. The spinning blades turn into shafts connected to a generator, and inside the generator, magnets rotate around the core of wire, producing electricity. The electricity is sent through power lines to homes, schools, and businesses. Wind farms can be built on land or offshore in ocean, where winds are stronger and more consistent. And what are the benefits of using wind energy? Wind energy offers several strong advantages, and that first is renewable and unlimited. As long as the wind blows, we have energy. Next is no pollution. Wind turbines produce electricity without smoke or greenhouse gases. Next is low operational cost. Once a turbine is built, it costs very little to maintain. Next is reduce dependence on fossil fuels like coal and oil. However, wind energy also has limitation. First is wind is not always consistent. If there's no wind, there's no electricity, and wind turbines require large open spaces, especially for big wind farms. Next is some people say turbines affect visual landscape and make low noise. Another one is they can sometimes affect birds and wildfire. All through newer design reduce the risk. And lastly, it requires high initial cost. Building turbines is expensive at the start, even though they're cheap to maintain. Now let's move on to hydropower or hydroelectric energy. Hydropower or hydroelectric energy comes from the movement of water. This can be flowing rivers, waterfalls, or water stored behind dams. Water naturally contains energy because of its movements and pressure. And how do hydropower works? The hydropower process is simple but powerful. First, the water flows with the force through the turbine. The turbine blades rotate as water moves past them. These blades are connected to a generator. When the turbines spin, the generator produces electricity, and the electricity travels to transmission lines and reaches consumer. Dams like Hoover Dam store huge amounts of water. When electricity is needed, water is released through the turbines, allowing us to control when its power is generated. And what are the benefits of using hydropower or hydroelectric energy? First is highly reliable. Water flow can be controlled, making energy supply stable. Next is large energy output. Dams can power entire cities. Another one is no greenhouse gases emission during operation. And last is support irrigation and water supply, since dams also store water for communities. And benefits, hydropower has challenges. First is high construction cost. Building dams can cost billions. Another one is environmental impact. Dams can affect rivers, fish migration, and natural habitats. Next is relocation of communities. Some large dams require communities to move. Next is dependent on rainfall. Droughts can reduce water flow and energy production. And lastly, risk of flooding if dam fails. Through this is rare with modern safety standards.
Now let's tackle the tidal energy. The tidal energy is the electricity produced from the natural rise and fall of the sea levels. As the tides move in and out, they create strong water currents. These currents can turn underwater turbines like wind turbines, which then generate electricity. There are two common ways to capture tidal energy. First is the tidal stream systems, where underwater turbines are placed in fast-moving tidal areas. As water flows through, the turbines spin and produce power. Second is the tidal barrages, which are like small dams built across river mouths or bays. Water is trapped during high tide and released during low tide, pushing turbines to generate electricity. Tidal energy is considered renewable because tides are created by the gravitational pull of the moon and the sun, which will not run out. This means that the energy source is natural, predictable, and sustainable. Tidal energy is very reliable because tides follow a regular schedule. It also produces no greenhouse gases, which means it is environmental friendly. And since it uses existing coastlines, it can support coastal communities with clean and steady power. However, tidal systems can be expensive to build, and they affect marine life or nearby habitats if not carefully designed. Because of this, engineers must balance efficiency with environmental protection. Tidal energy costs $280 per megawatt hour, which is equivalent to 16,240 pesos per megawatt hour. They are expensive to build. It is due to the high construction and top seawater maintenance. It also has limited locations.
because it meets coastlines and tidal range of above 3 meters and the current tidal speed of 1.5 to 2 meter per second, which only a few places qualify globally. And last is the biomass energy. Biomass refers to any organic material that comes from plants or animals. This includes wood, crops, agricultural waste, food scraps, and even manure. When these materials are processed, they can turn into useful energy. There are several ways to convert biomass into energy. First is the direct burning. Biomass like wood or crop residues is burned to produce heat, which can be used for cooking or to generate electricity. Second is the biofuels. Biofuels like materials like corn, sugarcane, or vegetable oil can be turned into liquid fuels such as ethanol or biodiesel, which can power vehicles. And last is the biogas. Waste materials are placed in closed tanks. And lastly is the biomass energy. Biomass refers to any organic material that comes from plants or animals. This includes woods, crops, agricultural waste, food scraps, and even manure. When these materials are processed, they can be turned into useful energy. There are several ways that convert biomass into energy. First is the direct burning. Biomass like wood or crop residues is burned to produce heat, which can be used for cooking or to generate electricity. Second is the biofuels. Materials like corn, sugarcane, or vegetable oil can be turned into liquid fuels such as ethanol or biodiesel, which can power vehicles. And lastly is the biogas. Waste materials are placed in closed tanks which they decompose and release methane gas. These gas can be captured and used for cooking, heating, or electricity. And why is biomass energy renewable? Biomass is considered renewable because plants can grow again, and organic waste is constantly produced. As long as resources are managed responsibly, such as replanting trees or using agricultural waste, biomass can be continuously replenished. Biomass energy helps reduce waste by using materials like garbage, agricultural waste, and other organic leftovers as fuels, which can help reduce the amount of trash going into landfills. It can also lower greenhouse gases, especially when replacing fossil fuels. And unlike solar and wind energy that depends on weather, biomass plants can generate electricity whenever fuel is available, making it a steady energy source. This type of energy can also support rural communities by creating local jobs in farming and fuel production. However, biomass still produces some emissions when burned, and large-scale biomass production can lead to deforestation or competition with food crops if not managed properly. Sustainable planning is necessary to avoid these issues.
Renewable energy from solar, geothermal, wind, hydropower, tidal, and biomass energy proves that we can power our world naturally, cleaner, safer, and with less reliance on non-renewable energy. These energy types reduces pollution, cuts carbon emission, and lessens our reliance on non-renewable sources like fossil fuels. Shifting into renewables is essential for protecting our environment and securing a healthier future for the next generations. The energy of tomorrow lies not in what we consume, but in what we preserve.